Good afternoon. Last year, more than 45 billion devices were connected to the internet. Over 60% of the world population had access to the internet. So we actually live in a hyper-connected era. More and more devices will be connected. Every year, millions of devices are connected to the internet, and they all produce data. They all have some form of compute, they all have some form of storage, but they all also produce data. And the data is then being transferred into larger storage areas, storage facilities, and that's only increasing. There was a statistic that only in this year, 94 zettabyte of data is being transported over the internet. That's quite a lot. The users are also more and more demanding. We had this great presentation this morning, even a bit scary, I think, if you look at it, but around artificial intelligence. Again, all producing data in any way of any form, and that data needs to be transported again. So what is key is, where do you store data? Because we all need lower latency. And the connectivity between those data hubs becomes more and more key. So latency makes sure that we have to push data closer to the edge. So the question is, where is the edge? We had a presentation earlier around the edge. There are very broad definitions around edge compute and what the edge is. Most used is the one on the left. So you have a core site where your main compute is located. Infrastructure, so smaller sites pushed into your region, closer to the carriers or to the telcos. And then you have sites inside the telco, and you have sites maybe on street level or in 5G next to the base station. For us as a data center business, we look at it a bit different. So we look at core, regional, and edge. So we see the business in core, we see the business in region, and then slowly pushing to an edge. Again, where you put the data matters. Latency impact nowadays, it's not really there. We don't see the use case yet. And if you saw the presentation this morning from Olaf, it's slowly getting there, but we're not there yet. There is no need for very low latency, especially if you look, for instance, in the Netherlands. We don't have a latency issue. The country is not that big, so as Olaf was also mentioning, with one data center, you can reach quite the rest of the Netherlands. That will change, of course. So with new applications, you will see the need for lower latency, sub 5 milliseconds. And that means that you have to expand on where you would deploy your data, where you would deploy your application layer. So that could be autonomous drones, that could be artificial intelligence, that could be virtual or augmented reality. So where are you going to render augmented reality videos? Do you do that in the central data center, or do you push that to the edge? And where is that edge? Is that really already necessary to put it into a base station from a 5G tower? Or can you still do it with one or two different data centers in country? So again, it matters where you put your application, and it matters where you put your data. From a data perspective, as I mentioned, more and more devices connected to the internet, more and more devices that will generate data. And it's sort of evolving quite fast in that time. So if you start with applications and you start generating data, there are more and more applications that can use that data to get some more type of information out of it. But it also generates, again, data. So you will have data sets that are moving around between applications, maybe moving around between data centers. And that's increasing by the amount of applications that are using the data. And therefore, the more data you need to transport, the longer it takes to get the data from one application set to the other application set. Again, it matters where you put that data. So with that, and the latency issue I mentioned, you will get more and more facilities that evolve around that data set. So a center of data instead of a data center. So where are we? And what do we see happening? As I mentioned, at this moment, there is no real issue with latency. Yes, we have low latency services, but as I mentioned in the presentation, or the question was actually on the presentation of Olaf, is the current internet capable of delivering what we need? So far, yes. Do we need to expand on that? Yes, of course. But it's a bit of the chicken and egg, because if we don't have the application that needs that lower latency, we don't have to build for that lower latency. And so people are still waiting, or companies are still waiting to deploy low latency infrastructure because there's no real need for it. If you look at 5G, 5G is promising, but for now it's being used most of the time for B2C, so for the consumer. The consumer is not going to pay for additional infrastructure. So the promise of 5G is B2B, but we don't see it yet. So therefore, mobile operators are building 5G, but they're not building the small cells that are needed for low latency applications. That doesn't mean that nothing is happening on edge. There are a lot of things that are happening on edge. So we see CDNs that are going deeper inside the internet infrastructure. They're going closer to the eyeballs. So they're restructuring their infrastructure. We also see the larger cloud companies doing a cloud out proposition and building regional cloud data centers. So there are things happening. Again, on the long term, that's where we want to be. But it will take a few more years to get there. Augmented reality, artificial intelligence, it's coming, as we saw this morning. But to become mainstream and to have the infrastructure ready to deliver that via 5G, for instance, that will take a few more years. So what we see happening is that, yes, there is a move from core sites to regional sites, sometimes to smaller edge locations, again, depending on how you define what the edge location is. But we see that move happening, but it's slowly. And again, if you combine it with what I mentioned earlier, with a data set that has to be moving from one location to the other, it's all about latency and it's all about the connectivity in between. So edge is really latency and connectivity driven. So edge on the move. As I mentioned, what we see happening with CDNs is that they are decoupling, let's say, that traditional cache layer that they had from their underlying infrastructure, which means that now they're able to run additional applications. So most of the CDNs, first of all, will go into security services. That's nice, but it's not the end state. They are able to run additional applications. So they're actually the first edge companies. They were already the first edge companies, but only focusing on caching, only focusing on delivering traffic. Now they're also focusing on maybe getting traffic inside and then do some compute on an edge location and then deliver, let's say, anonymous data back to a core location. We see that happening with our customers, our CDN customers. So again, they are able to run additional applications. With the likes of artificial intelligence, with the likes of virtual reality, augmented reality, there is a definite need to move closer to the eyeball, closer to the user. And therefore, what you already saw with the cloud companies, with that cloud out progress that they're making, they're building these smaller regional data centers. But then again, they still need to have that connectivity to that central location, and they need to have that connectivity to the eyeball. So really focusing again on latency. So what we see happening is, and it was also mentioned earlier by Olaf, so it all comes nicely together, hybrid deployments. We see that our customers are looking to deploy their core sites and looking to deploy smaller compute slash storage sites, and then pure compute or connectivity sites at the edge. So that's a process that's ongoing. As said, that's why we call it the moving edge. That's where CDNs are moving first, but they're followed by other providers. And that's how we came with the term, the moving edge. Again, it's a flexible move from core sites to edge locations, and the ability to shift workloads, to shift data sets from one location, so from the edge location back into that central compute location, or back into that edge if needed to provide, again, for instance, rendering for augmented reality. So moving edge, flexible deployments, latency-driven. And that latency-driven part, that obviously is quite important, and my colleague from Ciena will explain how that is being implemented.
Thank you, Wilfried. Okay? Yeah, very good. All right, so let's move now to the network, because I guess it's pretty important to talk about the network. As of now, and as Wilfried pointed out, connectivity has never been so important. And as of today, connectivity is already existing between data centers in the same metropolitan areas. And if you look at the leading data center operators, including Interxion, they've all deployed very high capacity optical networks between their data centers in the same metropolitan area. Okay? There is another form of connectivity that we are going to touch a little bit after. That's the end user connectivity to the edge, or to the cloud edge. And if I come back to the data center connectivity in the same metropolitan area, the main objective for Interxion, as an example, is to offer their end customer the same environment, whatever the data center they put their IT infrastructure in. In other words, it's like all Interxion and customers benefit from the same partner ecosystem. So the same connectivity ecosystem. It's like a bit, they can put their infrastructure into one data center as if it would be part of a virtual data center without walls. So the main characteristic of a connectivity product, like Metro Connect Managed Wave as an example, is of course ultra low latency. There is no other way to transport data faster than over light, and that's what we do at Ciena. We transport data over light. And of course, we are always sub-millisecond in this type of networks, but most of the time, it's really a few microseconds. And so you've got dedicated bandwidth, there is no, of course, there is no traffic engineering, and we don't touch data, and we can deliver traffic from 10 gigi to 100 gigi and even 400 gigi. And I think the SLA that Interxion is offering, the lower SLA is 4.9. And of course, you've got all the equipment redundancy, you've got diverse fiber paths. It's very, very secure as a connectivity. And it's almost unlimited capacity. So it's, on one dark fiber pair, you can transport 20 terabit and even more depending on, the technology you are using. And here you've got an example of the solution that we are positioning. It's very small footprint. As you can see, it's 1 RU, and only this box can transport 2.4 terabit of data. So that's quite impressive. And here you've got a list of the city where Interxion is offering their Metro Connect managed wave, so this kind of services. So as you can see, it's available across a large number of metros in Europe. So now let's move to the edge and let's give some perspective about what are the factors that will drive this move toward the edge. So first of all, I'd say that the enterprise, they have started to realize that moving to the edge is going to help them be successful into their digital transformation and stay competitive into their market. So they're not going to have any choice. They have to move their data to the edge. And I would say even to the cloud, because most of the enterprise, they see the edge as a kind of natural extension of the cloud. And the reason for it is that they know that the edge will offer very low latency, as Wilfried pointed out. So maybe the application is still not there, but that will come for sure. They're also going to save a lot of money with regards to better efficiency at the network level, as well as operational savings. And they will keep a very good control, good control of their data. So all in all, I think that they have completely understood that it will be a key success factor in order to deliver their digital transformation. So a data that is very, impressive to me is that 83% basically of data is still not in the cloud. So of course, when you see that, you cannot avoid from thinking that it is a huge opportunity for cloud providers, for data center operators, as well as telcos. And for sure, they are going to grab that opportunity, believe me. And that's why they have started to multiply their presence at the access. And also the telcos are starting to offer edge services on top of their more standard, I would say, network services. So all in all, I would say this market is quite huge because only this year, edge services is expected to be $97 billion and is going to double, by 2026. And now let's talk about, so I'll stay high level, but let's talk about the technical aspects. Of course, Ciena is willing to help enterprise and end users to get access to this edge or to this edge cloud, let's say. And for making that possible, we have developed a number of technologies. And the first one I would like to point out, is a Coherent Edgeline system. So basically, this system that is very low cost, small footprint, is 1 RU, is able to transport up to 10 wavelengths, so 10 times 400 gigi, if you will, over 80 kilometers. So low cost, only 1 RU, it's pretty much plug and play, and it will help the end users, the enterprise, to get connected to the first edge with the first cloud. Okay. And another technology that probably you started to hear about is the 400 gig ZR. So what is 400 gig ZR? So basically, it is this, I don't have any pointer, but that's this plug. And this plug is able to transport 400 gig of traffic over 80 kilometers. Okay? So it's very small, it's low power, low footprint. And basically, you can use this kind of plugs to transport the data with the same Edgeline system. And the beauty of this is that it has been defined by standards organizations like OIF, and it is MSA compliant as well, is that you can use this kind of plug either into some demarcation platform, like the one you can see here, or also directly into a switch or a router. And the beauty of that is that it's going to interpret. So you can use either those plugs, as I said, directly into an edge router, or if you want to still keep a demarcation with your network, you can use this demarcation platform. So this technologies have been designed properly to address the edge and the access, because we expect at Ciena that it's going to be the next area where investment is going to be done. Probably we'll offload some data from the core network as well and moving to the edge. So that's why we have developed this kind of purpose-built, low-cost and small footprint solution to address that need. So that's it for me. So I don't know if you have... Wilfried, if you maybe have any question or... Okay. Maybe I need to...
Okay.
Sorry.
No worries. Okay, so do we have any questions for the gentleman? No? Okay. Well, I have a couple. Maybe a little bit more basic ones that might be pointed at Wilfried. When you were talking earlier about the edge, okay, so you say we're not there yet that the internet is meeting the latency requirements where we are, roughly speaking. But as that develops and you know, these applications create a higher demand for lower latency, I'm just wondering how far will you push that edge? I mean, well, if we're in a place like Hong Kong or something, will it end up in the basement of an apartment building? Does it go to the campus of a university or the car park of a sports arena?
So when we started to talk about edge, and I've been doing presentations on edge since, I think, 2017 or something like that. So when we started, it was all around what 5G will bring. So we were always talking, okay, and there were some projects to create micro data centers close to a base station. So the promise was always that's where we are going to be. So a micro data center close to a base station, or maybe inside the network of a DSL provider or cable provider. That sort of shifted back because at that time there was no need for it. But if you saw that the approach I gave, then you also see the device layer. So yes, eventually edge can be a device inside your living room, inside your next to your DSL router, for instance, that has those capabilities. So, and again, that's why it's the moving edge. We're not there yet. We're moving into that direction. And eventually, if there's a need for low latency applications that need rendering or compute really close to the eyeball, so in your household or at the base station, then it will happen. But all attempts to build something there so far didn't succeed because the need is not there.
Okay. Any other questions? I did have one more, a little bit along those lines. I'm also curious, not to that extreme, but are the demands ever elastic? I mean, do you sort of think of a build out, perhaps it's seasonal based or event based, campaign based and that sort of thing? Does that change the way you're designing or where you're placing the edge based on some of those factors?
I guess what you definitely see more and more happening is that we will go into flexible contracts. We get these demands from some of our customers as well. So, and for instance, that's something which you see happening with CDNs. They will deploy additional capacity because there's a World Cup soccer or something like that. That most probably will also happen if you have events where you do augmented reality or artificial intelligence. Then you will have an event where you need to deploy that. So that means that you will build a base infrastructure that is capable of handling that, but you need to be able to scale up and down later on if needed.
Okay. And finally, you mentioned drones and this sort of thing. Where were you going with some of the future efforts?
So there are a number of examples. So for instance, in the UK, there are warehouses where drones do automatic or autonomous inventory management. So they know from each other where they are flying. Is that an edge application? Not really, because it's a controlled, dedicated environment. But you also see, for instance, here already in the Netherlands, that there are drones flying above crops to define where they have to be watered more than other places. Or you have robots that are in the tulip fields with AI determine what are viruses and which of the bad tulips they have to pull out. That's all generating data, and obviously that data not necessarily have to go all back to a data center, but need to be processed closer. So one part is in the robot, one part is at the farm, and then maybe for the good of other farmers, some data is being processed in a central data center. So there are applications that are edge-like, but it's not that we already need the infrastructure for it.
If I may, maybe on the network, because you were talking about flexibility and also the consumption model. So I think one of the barriers at the moment is that the network is not that flexible. So sometimes, most of the time, you give like a 1 gigi or a 10 gigi or 100 gigi, and it's not really, the consumption model is not that flexible. So probably to remove that barrier and to help the move to the cloud, the network, they will have to be much more flexible. And they have to be consumed, as a per need model, if you will. So I expect to be much more automation and software, also into the network, and probably the telcos here in the room. That's what they are working on at the moment to make it, consumable, based on need. That's it.
Brilliant. Yeah. Okay, thank you both very much. Any takers? No, that's it. Okay, thank you both. Cheers.